Hello, 911. I'd like to report a crime. There are dirty, nasty words ruining my perfect, beautiful math problems, and I'm scared. Welcome, my friends, to our 9th class of Unit 5, where our goal is to, hopefully, get unscared. Or if that's too ambitious for you, at least a little less scared. Because today we want to see how we can go about modeling and solving some word problems using systems of equations. That's right, it's word problem time. But it's been a hot second since we've done some word problems together, so you might remember that the last time that we did word problems, we came up with a 5-step checklist, a potential best practice that could guide us through the process of writing and solving a system of equations, in this case from a word problem. Take a look back at your notes and see if you can find it, or maybe you've got this information already committed to memory. What are some of the things that I might want to look out for as I'm working on a word problem? Look back at your notes and see what you find, or maybe you've got that information stored in your mind palace somewhere. See if you can find the door it's behind. All right, go, go, go. And stop, stop, stop. So, depending on the types of problems that we're working with, we might want to do different things. One of those things, if, big on if, right? I'll, in parentheses, include, sometimes I might encounter a problem that has a visual dimension, in which case, giving myself a diagram or some kind of visual that represents the problem could be a powerful way to help aid in my cognition. From there, any problem that we solve, regardless of what it looks like, we always want to know what it is that we're solving for. The thing that tells us what we're solving for, or at least carries that information, is our variable. But in this case, of course, you're going to notice I'm going to write variables, because as we know, systems of equations contain multiple variables. From there, sometimes there might be a problem where there's a particular relationship that I want to weaponize, or a particular formula that I want to use. In those cases, giving myself some kind of graphic organizer, like a chart, could be a powerful way to help me keep track of the relationships between the information in my problem. After I've got all of that setup done, I definitely need something that I can solve. When we were working with equations, we wanted to build an equation. When we were working with inequalities, we wanted to build an inequality. Now that we're in systems land, we probably want to write and solve a system of equations. And last but not least, once that system is solved, the last thing that's important for me to do is just to make sure that my answer in context makes sense. Making sense, or sense-making, can mean a couple of different things. One thing that you definitely want to look out for, did you include the units that contextualize your answers in the context of the problem? But I might also want to check my work in the event that I want to do some substitution, but I could also do some kind of informal checks. If, for example, I end up with a negative number where I was solving for money, or for time, or for, like length, all of those could be indicators that something went weird. Cool, we've got our checklist. Let's see how it can help us when we solve a problem like this one. Sally is selling 2 types of seashells by the seashore, each for a fixed price. On one day, she sells 2 nautilus shells and 7 clam shells for a total of $46. The next, she sells 1 nautilus shell and 11 clam shells, earning $53. How much does Sally sell, tongue twister, each nautilus shell and each clam shell for? So we're going to move through this problem together, but before we do, I want you to take at least 30 seconds and pause the video. I could say here, a diagram wouldn't be especially helpful. I could draw some pretty shells, but that's not really going to help me solve, as pretty as they are. Let's start by defining our variables. So what is it that I'm looking for? And then in the context of the problem, what are some pieces of information that seem like they're going to be valuable to the system of equations that we will eventually want to write and solve? So again, pause the video. What am I looking for? And what are the pieces of information that seem like they're going to be important to the equations in my system? See what you come up with. Take a risk, take a chance. Have fun. Okay, that's too much fun. Let's get Shelly. We're not getting anybody named Shelly. Our person here is Sally. We're using Shelly as an adjective. Okay, I'm being silly. Be quiet, Mr. Villau. The thing that I'm looking for is often going to live, as we've hopefully noticed from experience is passed, at the end of the problem. The last sentence here is telling me that I'm dealing with both something to do with nautilus shells and something to do with clam shells. The thing specifically that I'm looking for is how much each one sells for. So I'm looking for their price or their cost. So my two variables, the things that I'm looking for, I need something for the cost of a nautilus shell. I'm going to choose N because nautilus, maybe you didn't notice, starts with N. So N specifically is representing the cost of each nautilus shell. I'm going to write that as the cost per nautilus shell, but you could say the cost of one, you could say the cost of each, however you want to phrase that. And then for clamshell, I'm going to make the radical decision to use the variable C. So C for clam will represent the cost of one of my clam shells. Now, with my variables defined, I need the equations that are going to contain them. Well, hopefully you noticed. For my two equations, I need two of them because I've got two variables. The thing that's going to help me determine what my two equations will be, I've got a first day and a next day. And in both of those, I've got something to do with nautilus and clam shells. So my first equation is going to represent what happens on the first day. My second equation will represent what happens on the next. Important information here. I'm selling 2 nautilus shells and 7 clam shells on the first day, and I make $46. On the second, I sell 1 nautilus shell and 11 clam shells, and I make $53. I, of course, am Sally. My name is legally Sally Volel. Okay, enough jokes. Let's solve a system. So, I need to find out how to build an equation from this. So if I'm selling 2 nautilus shells, and each one costs N dollars, I need a way to get to money. Well, we should hopefully feel really good about this by now. We've done a bunch of it so far this year. If I know that each shell costs N dollars, and I multiply that by the number of shells that I sell, so 2N, that should give me the total amount of money that I make from nautilus shells. Same idea for clam shells. If I take the cost of each shell and I multiply it by the number of shells that I sell, that should give me the total amount from clam shells. And I know when I add those two together, I should get my grand total of 46. Lovely! By exactly the same logic from my green equation, the next day, I sell 1 nautilus shell, so I've got 1 times the cost N, which I'm going to write as just N, and then I add that to my 11 clam shells times C, the cost for each one. Now I've got my total price of 53, which comes from summing the individual prices. There we go. Would you look at that? We've got a system that we can solve. If you haven't already, take 2 minutes, pause the video, see if you can solve for N and C, whichever method you like. Go! And stop. Let's get her done. So, I'm going to choose to solve this guy using elimination. No real reason why. Maybe I think I did substitution in the last video first. Let's do elimination first here. Doesn't really matter. So from here, notice in the top equation I have 2n. The easiest choice to make would be to multiply the bottom equation by 2 to get the 2n that I want. Doing so, my new system of equations, I've got the 2n plus 7c equals 46 on top. 2 times n is 2n, plus 2 times 11 is 22, so I've got 22c. 53 times 2 on the right is 106. Here I've got 2n and 2n. These guys have the same sign, so if I want to undo them, I probably want to subtract my two equations. 2n minus 2n, going piece by piece, is 0. 7c minus 22c is negative 15c. And then on the right, I have 46 minus 106. That is equal to negative 60. To get c by itself, all I now need to do is divide both sides by negative 15. 15 goes into 60 4 times, and I'm doing a negative divided by a negative, so positive 4 will be the value of c. But I'm not done. I still need to solve for n. So I'm going to substitute into one of my two equations. I'm going to choose to substitute into the bottom one because n already has a coefficient of 1. Doing my substitution, I have n plus 11c, but we've just established that c is the same as 4. All of that is equal to 53. So I have n plus 11 times 4, which is 44, equals 53. Finally, to get n by itself, I'm going to subtract 44 from both sides to show that n is equal to 9. Cool. Now, if I'm being really good, step 5, in context. I should write a sentence saying something like, Sally sells each Nautilus shell for $9 and each clamshell for $4. But, hypothetical full credit, all I really need is my units. Of course, I was talking about cost. So as long as I've got those dollar signs there, I'm happy. Cool. $9 per Nautilus, $4 for clam. Let's do one more like this, and then I'll show you one more form that systems of equations word problems often take. To make ends meet, an amateur artist takes commissions from clients for both digital and physical artwork. Last week, the artist completed 8 digital pieces and 2 physical pieces, and worked for 38 hours in total. This week, they have 5 digital and 3 physical pieces to finish, and they expect that it will take 36 hours to complete them all. How much time does it take the artist to complete a single digital piece and a single physical piece? So again, let's pause the video. I want to know what my variables are. What am I looking for? I want to know what pieces of information seem important to me. And then if I'm feeling really ambitious, I want to write and solve a system of equations that models this scenario. Take 2 minutes, pause the video, see how far you get. What am I looking for? What information is important? How can I use it to build a system? And then let's try to solve for our 2 variables. Go ahead. Okay, let's get artistic. So, looking at my last sentence, I'm looking specifically for the amount of time that it takes to complete 1 digital piece and 1 physical piece. Thinking strategically, that means my 2 variables, maybe I'll choose D to represent, in this case specifically, the amount of time that our artist spends on each digital piece. And I'll even include my units here. Right, if I'm talking about a measure of time, the measure that I'm given here for my unit in the problem is hours. By exactly the same logic, I'll choose the variable P to represent the amount of time per physical piece that my artist completes. In hours, of course. Cool. From here, I need to build my system. My 2 systems are probably going to come from my last week's stuff and my this week stuff. So let's start with last week. Last week, I've got 8 digital pieces and 2 physical pieces, 38 hours of work in total. So from that equation, if I take the 8 digital pieces that my artist created and multiply it by the time spent per digital piece, 8D here should give me the total amount of time spent on digital. And by the same logic, I'm going to add 2 times P, that should give me the amount of time on my physical pieces. Totaling that up gets me to 38. Same idea here. For my this week equation, I have 5 digital pieces, 3 physical pieces, and 36 hours in total. So if I take my 5 times the amount of time per digital, plus that 3 times the amount of time per physical, that should sum to my 36 hours. Cool. There is our system of equations. I'm going to choose to do this guy using substitution. So taking my top equation, I noticed that 8, 2, and 38 are all divisible by 2. So I'm going to choose to isolate P. So rewriting over here to the side, 8D plus 2P equals 38. Solving for P, let me start by subtracting 8D from both sides. That tells me that 2P is equal to 38 minus 8D. Dividing both sides by 2 to get P by itself, that tells me that P is equal to 38 divided by 2, which is 19, minus 8 divided by 2, which is 4D. Now that I've got P isolated in the top equation, I can substitute in for P in the bottom equation. Doing so, I can now rewrite my bottom equation as 5D plus 3P, but we've just established that P is equivalent to 19 minus 4D equals 36. Doing some distributive property, I'm going to take that 3 and distribute it to each of my terms there. So I've got 3 times 19, which is 57. I have 3 times negative 4D, which is negative 12D, and then that's equal to 36. Combining some like terms on the left side, I see 5D minus 12D. 5 minus 12 is 7D. So I've got negative 7, D, plus 57 equals 36. Subtracting 57 from both sides, 36 minus 57 is equal to negative 21. And now, dividing both sides by negative 7, I can show that D is equal to 3. Knowing that D is equal to 3, I now need to solve for P. Notice here, this equation is already solved for P, so I'm going to substitute there. So I know by substitution that P is equal to 19 minus 4D, but D we've established is 3. Therefore, P is equal to 19 minus 12. 19 minus 12 is 7. So if I'm being really good, I should write myself a sentence. It takes me 3 hours per digital piece and 7 hours per physical piece, but as long as I've got my units, my hypothetical full credit is earned. Yay! So here's one common setup for systems of equations problems. Another one that you might see might look something like this guy. In the Earth Kingdom capital of Ba Sing Se, a street vendor earns $60 selling 2 varieties of cabbage, green cabbages which sell for $4 each, and red cabbages which are $6 a piece. On one day, he sells a total of 13 cabbages. How many of each type of cabbage does the street vendor sell? So you might recognize the start of this problem as our first word problem from Unit 4, my little avatar reference that I did with Mama Volel. But notice there's something a little bit different here. I'm not working with 2 separate days. Instead, the information that I'm given is the total amount of cabbages that my cabbage vendor is selling. Think strategically here, think creatively. How could I take these 2 pieces of information and build a system of equations? Take a risk, take a chance, see what you come up with. Go ahead. And stop. So again, a diagram is not going to be especially helpful here. Let me start by defining my variables. I want to know how many of each type of cabbage I sell. I've got 2 different types of cabbages. Again, I am the cabbage seller, obviously. So I need 2 variables, one of them to represent the green cabbages. So I'll choose G for green. And then red cabbages, I'll choose R for red. Specifically, I want how many of them. So I'll say G will represent not just green cabbages, but the number of green cabbages that our vendor is selling. And then R will be the number of red cabbages that we sell. Lovely. Now, I need to think about how the information in my problem is communicated to me. Well, the first sentence, or the first part of the sentence, seems like a familiar setup. I've got a total of $60. I have green cabbages that are $4 each, and red cabbages that are $6 each. So that equation should be familiar to me. If I take the $4 per green cabbage and multiply it by the number of green cabbages, there's my total from green cabbages, plus I have $6 per red cabbage plus the number of red cabbages that we sell. When I add those together, I should get my $60. My second equation, though, might not be so obvious. The only other piece of information that I haven't used is that I've got 13 cabbages sold in total. Well, notice here that G is the number of green cabbages and R is the number of red cabbages. If we sell 13 cabbages in total, how can I combine those pieces of information to build an equation? What do you think? Take 20 seconds, pause the video. How could I use that information to build my second equation? Go. And stop. So here, if I'm selling 13 cabbages in total, if G is the number of green cabbages and R is the number of red cabbages, what that should hopefully tell me is that if I add the number of green cabbages to the number of red cabbages, I should have 13 of them in total. There you go. There's your setup for your system. If you haven't already, take 2 minutes, pause the video. Let's solve for G and R. Go ahead. And stop. So let's solve this one with substitution. It doesn't really matter which way. I'm going to choose to isolate G in the bottom equation. You are absolutely welcome to do some elimination here. Subtracting R from both sides, I can show that G is equal to 13 minus R. Now I can take that G and substitute it into my top equation. Every time I see a G in the top equation, I'm going to rewrite it as the equivalent 13 minus R in parentheses. So I have 4 times 13 minus R plus 6R is equal to 60. Solving for R now, let's start by doing some distributive property. 4 times 13 is 52 minus 4 times R, which is 4R, plus 6R equals 60. Combining some like terms, negative 4 plus 6 is going to give me 2R, and then I have that 52 over to the left, and I'm equal to 60 on the right. Subtracting 52 from both sides, that tells me that 2R is equal to 8, and if I divide both sides by 2, I can show that my number of red cabbages is 4. So I'm selling 4 red cabbages, and now I need to find the number of green cabbages that I sell. Well, strategically, my goal is to solve for G. Notice this equation down here has already solved for G. So I've got 13 minus R, the number of red cabbages, which we just found was 4. 13 minus 4 is equal to 9 cabbages.